Welcome to those who may be watching this presentation. I'm Leardt and will be presenting this Engineering Honours Research and Development project with my associates Caleb and Sharne. This project is concerning the design and development of compliant mechanisms for robotic grippers. To introduce the project, it is important to understand the issues faced by the kiwifruit industry. In New Zealand, kiwifruit is the biggest horticultural export in both volume and revenue. Due to the significant size of the industry, there is always difficulty surrounding the hiring of enough employees for kiwifruit harvesting. This issue is further emphasised by current events such as COVID, which has prevented the hiring of migrant workers who often fill this employment gap. Previous solutions have investigated robotic harvesting of kiwifruit. This has yielded some success, but some of the downsides have included the robots needing constant maintenance due to the outdoor environment, which leads to downtime of the robotic harvesters. Therefore, to resolve some of these issues faced by current robotic harvesters that use traditional mechanisms, we are looking to modify robotic harvesters to utilise compliant grippers to improve efficiency and quality of harvesting. The method in which conventional robotic gripper operates is by using an assembly of components connected at movable joints such as hinges and bearings to create a rigid mechanism. One of these greatest downsides to traditional mechanisms is that they experience friction and their movable joints often leading to wear-induced failure. Some other difficulties associated with these forms of rigid mechanisms is that they are very expensive, require assembly, lubrication, and regular maintenance due to harsh outdoor environments. To describe compliant mechanisms, they essentially perform the same operation as traditional mechanisms, but rather than utilizing features such as hinges and bearings, they perform the desired operations through elastic deformation. Compliant mechanisms offer many advantages over traditional mechanisms, with the major advantages being that they require no maintenance, be reduced at a reduced cost, and offer increased precision.
Our design for a compliant gripper can be seen on the slide in front of you, where it consists of two fingers for gripping and the two cross members are where force is applied. Through the images on the left, you can see how the mechanism deforms to complete the grasping motion, as a downward force is applied to the top cross member and the bottom member is held stationary. The design was intentionally kept simple and two-dimensional, as it allowed for easier manufacturing through both 3D printing and CNC machining. To increase the friction of the design and contact area with the kiwifruit, detachable finger inserts were also developed, which are 3D printed using soft TPU to avoid damage to the kiwifruit. These can be seen clipped onto the ends of the fingers in the image on the right. For our compliant mechanism to achieve its full potential, a lot of optimization was required. Little is known about the compliant mechanism design process, and therefore it required a large amount of geometrical optimization to create a design that achieved the required deformation without generating excessive internal forces. To achieve the right design, many iterations of the gripper were prototyped and tested using finite element analysis, which allowed us to arrive at our optimized final design. Some of the changes we made along the way were reducing the number of supporting struts, the addition of nodes to key deformation areas, and critiquing the angles of many members. To further optimize the compliant mechanism, an investigation into two different manufacturing methods was conducted, which were 3D printing and CNC machining. We ran several tests to determine the optimum 3D printing parameters, which included material, raster orientation, and print temperatures. And then after this, we determined the optimum parameters for CNC machining the mechanism from rolled polymeric sheet, which mainly focused on the rolling orientation. So finally, after we compared between the best achievable 3D printed compliant mechanism and the best achievable CNC machined compliant mechanism, we arrived at the conclusion that CNC machining as a manufacturing method gave the best compliant mechanism performance.
Although the gripper was a major part of our design, the gripper required a method of actuation and housing to accompany it. Therefore, we designed aluminium housing that used a pneumatic actuator to compress the mechanism to achieve its grasping motion. This was then attached to an existing UR5 robotic design. Due to COVID restrictions, a testing comparison of the design to the current robotic kiwifruit harvesters was unable to occur. Therefore, for future, it would be ideal to conduct testing of the design in the field and conduct further optimization procedures. Our solution, provided it is successful in the field, would be an optimal solution that could be applied to other horticultural sectors that are also facing labour shortages such as apples and avocados.